Have you ever looked up at the night sky and wondered, not just how it all began, but how it will all end? We're all familiar with the Big Bang theory, a single explosive moment that kick-started everything we know. But what if that wasn't the beginning? What if it was just the latest beginning? Today we're diving into one of the most mind-bending ideas in cosmology, the Cyclical Universe theory. Forget a single timeline stretching from a definite start to an unknown end. Instead, picture the universe as a cosmic phoenix, endlessly dying and being reborn from its own ashes. The standard model, the Big Bang, tells a fantastic story. About 13.8 billion years ago, all matter and energy in the universe was concentrated into an infinitesimally small, hot, dense point. Then bang! It expanded, cooled, and over billions of years formed the stars, galaxies, and planets we see today. It's a powerful and well-supported theory, but it leaves some big questions unanswered. What came before the Big Bang? What caused it? And what happens at the very end? The prevailing heat-death scenario is a bit grim. It suggests the universe will keep expanding forever, everything will cool down, stars will burn out, and eventually, all that will be left is a cold, dark, empty void. An eternal, silent darkness. Not exactly a cheerful thought, right? But what if there's an alternative? This is where the cyclical universe model comes in, proposing that the end is also a beginning. The idea isn't new. It has roots in ancient philosophies that saw time as a wheel rather than a straight line. But in modern physics, it takes on a whole new level of scientific rigor. One of the most popular versions of this idea is called the Big Bounce. Imagine the timeline of our universe not as a line, but as a wave. The Big Bang isn't the starting point, it's the peak of a crest after a deep trough. In this model, our universe is currently expanding, but this expansion won't go on forever. Eventually, the immense force of gravity will overcome the expansion's momentum and start to pull everything back together. Galaxies will rush toward each other, merging in a chaotic cosmic dance. The space between everything will shrink. The universe will get hotter and denser, reversing the process of the Big Bang. This cosmic collapse is often called the Big Crunch. Everything, stars, planets, black holes, all of it, would be squeezed back into that tiny, super hot, super dense state, similar to the one that started the Big Bang. But instead of just ending there in a singularity, a point of infinite density, where the laws of physics break down, something incredible happens. The universe bounces. The immense pressure and energy from the Big Crunch triggers a new, violent expansion, another Big Bang, and a new universe is born, with its own set of stars, galaxies, and potentially its own life. This cycle of Big Crunch followed by a Big Bang could repeat forever, an eternal cosmic heartbeat. Now you might be thinking, if this is true, is each new universe an exact copy of the last one? Probably not. The theory suggests that with each cycle, the fundamental conditions could be slightly different. Maybe the physical constants change just a tiny bit. Perhaps the distribution of matter and energy is shuffled. This has some profound implications. It means our universe, with its specific laws of physics that are perfectly tuned to allow for stars, planets, and life to exist, might not be a 1 in a trillion fluke. Instead, it could be the result of countless cosmic re-rolls. Over trillions upon trillions of years, across an infinite number of cycles, a universe with just the right conditions for us was bound to happen eventually. We are, in this view, an inevitable outcome of cosmic evolution on the grandest scale imaginable. But wait, there's a problem. Observations show that our universe's expansion is actually accelerating, not slowing down. This is attributed to a mysterious force called dark energy, which seems to be pushing everything apart. If dark energy continues to dominate, it would lead to that lonely heat death, not a big crunch. So, does that mean the Big Bounce is off the table? Not necessarily. Some physicists are working on models that don't require a big crunch. One fascinating idea comes from string theory and is called the ekpyrotic universe, or brain cosmology. Stay with me here, because this is where it gets really wild. Imagine our universe as a three-dimensional brain. Think of it like a giant sheet of paper, floating in a higher dimensional space. Now, imagine another brain universe floating parallel to ours. In this model, the Big Bang wasn't a singularity, but the result of these two brain universes colliding. The collision would release a tremendous amount of energy, heating our brain and causing it to expand, what we perceive as the Big Bang. After the collision, the brains pull apart, and our universe cools and evolves just as we've observed. But they don't just fly apart forever. An invisible force, like a cosmic spring, eventually pulls them back together for another collision, another bang, and the start of another cycle. The beauty of this model is that it doesn't require a big crunch. The universe within our brain can keep expanding forever. The cycles are driven by the interaction in that hidden higher dimension. It also elegantly explains the source of the Big Bang's energy. It's the kinetic energy of the collision. And what about the differences between cycles? Each collision might not be perfectly uniform. Ripples and imperfections from the previous cycle could carry over, creating the seeds for the structure in the next. So, each universe would have a memory, a faint echo of the one that came before. Each cycle isn't a perfect reset, but a new chapter in an epic, unending story. Think about what this means. If the universe is cyclical, then in a way, nothing is ever truly lost. The matter and energy that make up you, me, our planet, and our sun will one day be crunched down or re-energized in a cosmic collision. But then, they will be reborn. They will go on to form new stars, new galaxies, and perhaps new forms of consciousness in a universe that we can't even imagine. This idea transforms our place in the cosmos. Instead of being a fleeting blip in a single finite story, we are part of an infinite, regenerative process. The end of our universe wouldn't be a final, silent tragedy. It would be the dramatic prelude to another grand opening. It's a vision of the cosmos that is not just vast, but eternal and resilient. Of course, this is all still theoretical. We don't have definitive proof for a cyclical universe. Scientists are looking for clues in the cosmic microwave background radiation, the faint afterglow of the Big Bang, for specific patterns that might hint at a pre-bang era or a cyclic past. Future telescopes and experiments might give us the answers. But whether the universe is a one-time event or an endless cycle, exploring these ideas pushes the boundaries of our knowledge and our imagination. It forces us to ask the biggest questions of all. Where did we come from? Where are we going? And is the end truly the end? Or is it just the beginning of the next great adventure? What do you think? Does the idea of a single Big Bang or an eternal Big Bounce make more sense to you? Let me know your thoughts down in the comments. It's a huge topic and I'd love to hear your perspective. Thanks so much for joining me on this journey through cosmic time. If you enjoyed this deep dive into the universe's biggest mysteries, make sure to hit that like button and subscribe for more mind-expanding content. And as always, keep looking up.
You have probably heard about the theory that there are other universes where alternate versions of you live out different lives. But did you know that this is actually a scientific theory? There is a reason to think that there could be an infinite amount of universes where every single possible outcome of every choice that has ever been made actually does happen. And if that sounds like a stretch, stick with me here because the theory actually starts with something that most scientists agree on. That would be the fact that space goes on forever. While we can only see so far into the universe thanks to the limitations of light in our telescopes, we know that the universe extends far beyond what we can observe. We know this because of how we know that the universe is expanding. The universe is expanding, and it has no boundaries, then it goes on forever. And if it goes on forever, then there must be infinite stars and planets. Now, this doesn't necessarily mean that there are other copies of Earth or other copies of you out there. It just means there's a lot more stars and planets out there. But that's where things get interesting. If we were to imagine that life arose on those other planets in the same way that it did here, and if those creatures on those worlds evolved in the same way that we did, then it stands to reason that there would be some planets out there that are almost exactly like Earth, except for one key difference. On some worlds, life would have taken a slightly different path. A different choice would have been made by somebody. And that choice would cause a butterfly effect, causing the world they lived on to become very different from the world that we live on. On some worlds, your ancestors may have decided to stay on the African continent instead of migrating to Europe, which would have led to a completely different cultural and societal development. In another world, maybe you are the one who decides to stay in high school and not drop out, which leads you to getting a degree in astrophysics and eventually becoming an astronaut. Or maybe you choose pizza over hamburgers, leading to a completely different nutritional development. Okay, I know you're still thinking that none of these scenarios are that plausible. Stick with me here because this is where things start to get crazy. There are some scientists who believe that there are other universes where every single possible outcome of every choice that has ever been made actually does happen. This is the infinite universe theory, sometimes called the many worlds interpretation of quantum mechanics. And it says that every time a choice is made, every possibility of where that choice could lead splits off into its own universe. So yes, this does mean that there is an infinite number of versions of you out there, you and I, all living out different lives on different Earths in different universes. In fact, according to this theory, when you make a choice, every possible outcome of that decision is actually created. And each of those outcomes will actually happen in a different universe. So for example, let's say you're hungry and you need to decide whether you want a cheeseburger or a pastrami sandwich. Well, in one universe, you decide on the cheeseburger, and in another universe, you decide on the pastrami sandwich. And in yet another universe, you decide to eat both the cheeseburger and the pastrami sandwich. Yes, even the absurd options where nothing makes any sense are included in this model. Of course, you don't know about these other universes because you exist in only one of them, the one where you didn't eat the pastrami and cheeseburger at the same time. But according to this theory, all of those other versions of you do know about other versions of you because they exist in a universe where multiple versions of you coexist. For example, in some universes, your decisions may have led you to win the Nobel Prize for inventing the perpetual motion machine. And so in those universes, you know that there are other versions of you that failed to invent the perpetual motion machine. But why should you believe in this version of the multiverse? What evidence do we have for it? Well, we actually have some evidence that there could be other universes. Not necessarily other copies of you, but other universes. Let me explain. One of the foundational theories of quantum mechanics is called superpositions. This is the idea that until something is measured, quantum objects exist in a superposition of states, meaning that they exist in all possible states at once. Imagine that you have a box, and inside of the box there is a particle, and that particle exists in two possible states, either spin up or spin down. If you open the box and measure the particle, you will find that it is either spinning up or down, but you don't know which until you actually measure it. According to quantum mechanics, before you measured it, the particle was in a superposition of both states, meaning that it was in both states at the same time. But the moment you measure it, the wave function collapses and it lands in only one of those states. Now this seems pretty weird, and really it is. If you think about it, we can never actually measure anything without interacting with it. And if you interact with it, you must disturb it in some way. So really, a measurement is just an interaction that causes the wave function to collapse. It isn't a special action that magically causes the wave function to collapse. It's just an ordinary physical interaction. But if we assume that all interactions cause the wave function to collapse, then we have a problem. That's because this would mean that particles are never really in a superposition of states. They are either in one state or the other. All that happens is that their wave functions spread out, and then they interact with other particles, causing their wave functions to collapse. But if that happens, then the first particle will always end up in one state or the other, meaning that we would never observe a superposition. How could we possibly reconcile our observations with this view of quantum mechanics? Well, some physicists have proposed that the solution to this is that every time a wave function collapses, it doesn't just collapse to one state, it collapses to all states equally likely. This would mean that all possible versions of the wave function are still viable, and so all possible versions of reality still exist. You would just need to randomly teleport to one of those parallel realities. This may sound silly, but scientists are actually investigating this phenomenon in particle accelerators, trying to look for evidence of parallel universes. So far, they haven't found any. But there is one experiment that I am personally invested in that might just find some evidence of parallel universes, and that is the search for dark matter. That's because dark matter is hypothetical. It is a theoretical type of matter that scientists think makes up roughly 80% of the mass in the universe. But since scientists have never actually observed dark matter, it is possible that it doesn't actually exist. Instead, there is a good chance that the effects we attribute to dark matter are actually caused by a modification to Einstein's theory of general relativity. Several researchers have shown that certain modifications to gravity, especially on large scales, can mimic the effect of dark matter. One of these alternative theories to dark matter is called the bimetric theory of gravity. And the thing that I am personally invested in is that this theory predicts the existence of a second type of gravity. This second type of gravity would only become noticeable at very large distances, like the distances between galaxies. But if it turns out that there is a second type of gravity, then this could be evidence that there are other universes where physics works differently. Because if we can show that there are multiple fundamental forces of nature, then this could suggest that there are multiple fundamental constants of nature. In other words, there could be other universes where gravity works differently. And those differences could be so great that life couldn't evolve in those universes the way that it did here. Of course, this is all just speculation. And while scientists are searching for evidence of multiverses, it is probably not going to lead to you learning that you have a doppelganger in another universe. But it is worth keeping up with, because science marches on. If you enjoyed this video, please make sure to subscribe and leave a comment below telling me what you think of this many worlds interpretation of the multiverse. Thanks for watching.